Let's start off by talking a little bit about reflections. The next set of transformations we're going to be studying aren't shifts, but instead are called reflections, and there's two of them we're going to be concerned with. The first one is the easier one, the reflection over the x-axis. So what I'm going to first do is I'm going to look at a couple of graphs, and I'm going to look at a graph of f at x and a graph g at x, where g at x is the negative of f at x. So notice the negative appears outside of the function, appears before the f at x. So what I'm going to look at here is the function f at x equals 2 to the x. You may remember before I did x squared, but it's going to make it a little bit easier as I move into the next part of the notes to use something that's not a parabola. So I'm going to take a look at f at x equals 2 to the x, and so I graphed that, and I picked some values in a table. I picked -2, -3, -2, -1, 0, 1, 2, and 3, and I did the computation out and plotted the points. So there's f at x equals 2 to the x. Now if I did g at x is -2 to the x. So I'm going to use the same function, but throw a negative out in front. Notice it doesn't affect the x's directly that I'm using, you might think, but it just affects the y's. I kept using all the same x's, -3, -2, -1, 0, 1, 2, and 3, and I get exactly the same y's, except I get them in the negative form. Notice when I throw the negative out in front of the function, all it does is reflects the whole graph over the x-axis. So it turns it upside down, you might think, but really it's a reflection over the x-axis. So it appears that g at x is nothing more than the reflection of f at x over the x-axis.